Okay, sixth graders, back for one last lesson for this unit, and we're looking at simple interest. By the end of this lesson, you want to be able to solve problems involving simple interest. Let's start by defining what interest actually is. Interest is an amount that is collected or paid for the use of money. So anytime somebody puts money in the bank, there is something called interest, or if you borrow money from a bank, you have to pay interest. Simple interest is money that is paid only on the principal, and the principal is the amount of money that is invested or borrowed. And we can find our simple interest by using a formula. I equals P times R times T, where I is the interest earned, P is the principal, so that's the original amount of money, R is the rate, in other words the percent that you're paying, but it's written as a decimal, and T is for the time that the money is invested. Now let's look at a few examples of some problems that would involve simple interest. If you notice on the top of the page, I included our formula for us to use again. So now we just want to find the missing values in each problem that we're looking at. So remember, I is interest, P is principal, R is your rate, and T is your time. In this first problem, we're looking for the amount of simple interest. So our I is equal to 225 times our rate written as a percent, so 3% would be 0.03, times the number of years that we're investing, or times 2. So we're just going to go ahead and just put that right in our calculator if we want. And once we do all that, we get that I is equal to 13.5. So in other words, on this particular account, if you invested $225 at 3% for 2 years, you'd earn $13.50. When you go and pause the video and see if you can figure out the next one on your own. This one's a little bit different because they give us the interest. Here, 300 is equal to our principal, which is 1,000, times our rate, which we don't know, so I'm going to put R, times our 5 years. What I would do here is actually simplify this side first. So 1,000 times 5 would be 5,000 times our rate is equal to 300. Since they're being multiplied, I'm going to go ahead and divide each side by 5,000. And if I take 3,000 or 300 and divide it by 5,000, I get an answer of 0.06, which is our rate, but that as a percent would be a 6% interest rate. Now let's put the simple interest in some context of some word problems. Olivia deposits $7,000 into an account that earns 7% simple interest, but how long would it take for her account to balance to reach $8,000? So assuming she doesn't do anything else. So since we want her to reach $8,000, the amount of interest she would have to earn would be the difference between the two, or 8,000 minus 7,000, which would be 1,000. So that would be the interest that she earned. So that has to equal our original amount, which is our principal, 7,000, our 7% interest rate, which as a decimal would be 0.07. And what we're trying to figure out here is about how long it would take, so we're looking for the time. Once again, I'm going to simplify the right-hand side of my equation by taking 7,000 times the 700ths, and I get 490. So 1,000 is equal to 490 times t. Since these are being multiplied, I'm going to divide, because that's the inverse operation. So now if I take 1,000 divided by 490, I get 2.0408, and so on, is equal to t. If Because it says about how long, we can go ahead and round. So we're going to say that it would take, the time would be approximately 2 years for her to earn, although we know it's going to be a little bit more. So now you can go ahead and pause the video and try the problem about Avery on your own. So if Avery deposits $6,000 in an account that earns 4% simple interest, about how long would it take the total amount in his account to reach $6,800? So once again, our interest, the difference between $6,000 and $6,800 would be about $800. His principal is $6,000 times his 4%, which is 0.04, times our t. So I'm going to take 6,000 times my 400ths, which gives me 240. So 800 is equal to 240 times t. Go ahead and divide both sides by 240, my inverse operation. And I get 3.33 is equal to my t. So it would take him about 3 1/3 years, because 0.3 repeating is 1/3.